Question 1. A physician orders vancomycin 1 gram to be infused over 2 hours. The 4 solution contains 500 milligrams of vancomycin in 100 milliliters. What is the infusion rate in ml/hr? I. 50 milliliters per hour. B. 100 milliliters per hour. C. 200 milliliters per hour. D. 400 milliliters per hour. Answer B. 100 milliliters per hour. This question tests your ability to calculate N4 infusion rate when the ordered dose differs from the available concentration and infusion time is given. The key is to first determine the total volume of medication needed for the ordered dose, then divide it by the infusion time. Since the order is for 1 gram, which is 1,000 milligrams, and the solution contains 500 milligrams in 100 milliliters, you will need 200 milliliters of the solution to provide the 1,000 milligrams dose. Infusing 200 milliliters over 2 hours means the rate should be 200 milliliters divided by 2 hours, resulting in 100 milliliters per hour. Accurate calculation of 4 infusion rates is crucial for patient safety in hospital settings. Always remember to convert all units, like grams to milligrams, before starting your calculations. Question 2. A patient weighs 165 pounds. The ordered medication dose is 5 milligrams per kilogram. How many milligrams of the medication should be administered? I. 375 milligrams. B. 750 milligrams. C. 825 milligrams. D. 1,650 milligrams. Answer I. 375 milligrams. This question assesses your ability to perform a weight-based dosage calculation. The core concept is to convert the patient's weight from pounds to kilograms and then multiply by the ordered dose per kilogram. To convert 165 pounds to kilograms, divide by 2 lbs/kg, which equals 75 kilograms. Then, multiply 75 kilograms by the ordered dose of 5 milligrams per kilogram to get 375 milligrams. Accurate weight conversions and dosage calculations are critical for patient safety, especially in pediatric or oncology settings where precise dosing is paramount. Always convert the weight to kilograms first when dealing with mg/kg dosing. Question 3. A prescription for metformin 500 milligrams tablet states, take 1 tablet by mouth twice daily for 30 days. How many tablets should be dispensed? I. 30 tablets. B. 60 tablets. C. 90 tablets. D. 120 tablets. Answer B. 60 tablets. This question evaluates your ability to calculate the total quantity of medication needed for a specific duration. The key is to determine the total number of doses per day and then multiply by the number of days in the prescription. The patient takes 1 tablet twice daily, meaning 2 tablets per day. For a 30-day supply, you multiply 2 tablets/day by 30 days, which equals 60 tablets. Accurately calculating the quantity to dispense is essential for patient adherence and proper inventory management in the pharmacy. Always ensure you account for all doses taken within a single day. Question 4. How many grams are in 1,500 milligrams? I. 0, 15 g. B. 1, 5 g. C. 15 g. D. 150 g. Answer B. 1, 5g. This question tests your knowledge of metric system conversions, specifically between milligrams, mg, and grams, g. The crucial conversion factor is that 1 gram equals 1,000 milligrams. To convert milligrams to grams, you divide the number of milligrams by 1,000. So, 1,500 milligrams divided by 1,000 milligrams per g results in 5 grams. Accurately converting between metric units is a fundamental skill in pharmacy to ensure correct medication preparation and dosing. Here's an easy way to remember it. To go from a smaller unit, milligrams, to a larger unit, grams, you always divide by 1,000, moving the decimal point 3 places to the left. Question 5. A pharmacy technician needs to prepare 1 liter of a 0.9% NaCl solution. How many grams of NaCl are needed? I. 9G, B, 9G, C, 90G, D, 900G. Answer B, 9G. This question assesses your understanding of percentage strength, specifically weight/volume, with V, and how to calculate the amount of solute needed. A 0.9% with V solution means there are 0.9 grams of active ingredient, ethyl, in every 100 milliliters of solution. To find the amount needed for 1 liter, first convert 1 liter to milliliters. 1L equals 1,000 milliliters. Then, set up a proportion. 0.9G/100 milliliters equals xg/1000 milliliters. Solving for x gives 0.9G * 1000 milliliters/100 milliliters equals 9 grams. This calculation is vital in compounding to prepare solutions of the correct strength. Remember that percent, with V, literally means grams per 100 milliliters. Question 6. A prescription calls for 0.25 mg of a drug. The available tablets are 0.125 mg. How many tablets should be given per dose? I. 0.5 tablet. B. 1 tablet. C. 2 tablets. D. 3 tablets. Answer C. 2 tablets. This question tests your basic dosage calculation skills, specifically determining the number of tablets needed per dose. The core concept is dividing the ordered dose by the strength of each available tablet. Here, the ordered dose is 0.25 mg, and the available tablets are 0.125 mg each, so 0.25 mg divided by 0.125 mg/tablet equals 2 tablets. This is a common and essential calculation pharmacy technicians perform daily to ensure patients receive the correct medication quantity. Always ensure the units of the ordered dose and the available strength match before performing the division. Question 7. A liquid medication is prescribed as 15 milliliters 3 times a day. What is the total daily dose in teaspoons? I. 3 teaspoons. B. 6 teaspoons. C. 9 teaspoons. D. 12 teaspoons. Answer C. 9 teaspoons. This question assesses your knowledge of household to metric conversions and calculating total daily doses. The key conversion to remember is that 1 teaspoon TSP is equivalent to 5 milliliters ml. First, calculate the total daily dose in milliliters. 15 milliliters per dose * 3 doses per day equals 45 milliliters per day. Then, convert this total volume to teaspoons by dividing by 5 milliliters per teaspoon. 45 milliliters divided by 5 milliliters per teaspoon equals 9 teaspoons. Accurate conversions are essential for patient safety, as household measurements can sometimes be imprecise. Remember that 1 teaspoon is always 5 milliliters. Question 8. A medication is to be diluted by mixing 25 milliliters of drug concentrate with 75 milliliters of diluent. What is the total final volume of the mixture? I. 25 milliliters. B. 50 milliliters. C. 75 milliliters. D. 100 milliliters. Answer D. 100 milliliters. This question tests your basic understanding of volume addition during compounding. The concept is that the final volume of a mixture is the sum of the volumes of all components added together. Here, you are mixing 25 milliliters of drug concentrate with 75 milliliters of diluent, so 25 milliliters plus 75 milliliters equals 100 milliliters. This simple addition is fundamental in compounding to ensure the correct final volume and concentration of a preparation. Always sum the individual volumes to find the total volume of a solution. Question 9. A prescription for a topical ointment specifies, apply thinly to affected area twice daily for 14 days. The tube contains 30 grams. If the patient uses approximately 1 gram per day, what is the day's supply? I. 14 days. B. 15 days. C. 28 days. D. 30 days. Answer D. 30 days. This question evaluates your ability to calculate the day's supply for a topical medication. The keywords "tube contains 30 grams" and "patient uses approximately 1 gram per day" are crucial. The concept is to divide the total quantity of medication by the daily amount used. So, 30 grams divided by 1 gram/day equals a 30-day supply, while the directions mention for 14 days. The question asks for the day's supply based on the actual usage and quantity, which is an important distinction for refills and insurance. Always use the actual quantity and daily usage to determine the true day's supply. Question 10. A bottle of medication costs the pharmacy $48.00. If the pharmacy applies a 25% markup, what is the markup amount in dollars? I. $12.00. B. $16.00. C. $20.00. D. $24.00. Answer: I. $12.00. This question tests your understanding of calculating a markup amount in pharmacy business math. The concept is to find a percentage of the original cost. To calculate the markup amount, you multiply the cost of the medication by the markup percentage. In this case, $48.00 multiplied by 25%, or 0.25, equals $12.00. This calculation helps determine the profit margin on a medication before other fees are added. Remember, a markup percentage is applied directly to the cost to find the profit portion. Question 11. An 4 solution is infusing at a rate of 75 milliliters per hour. How many minutes will it take to infuse 250 milliliters of solution? I. 150 minutes. B. 200 minutes. C. 250 minutes. D. 333 minutes. Answer: B. 200 minutes. This question assesses your ability to calculate the total infusion time and convert hours to minutes. First, calculate the infusion time in hours by dividing the total volume to be infused by the infusion rate. 250 milliliters divided by 75 milliliters per hour is almost equal to 333 hours. Then, convert the total hours to minutes by multiplying by 60 minutes/hour. 333 hours asterisk 60 minutes/hour equals 200 minutes. Understanding infusion times is crucial for coordinating medication administration in a hospital setting. Always remember to convert hours to minutes by multiplying by 60 for your final answer if needed. Question 12. A medication stock bottle contains 500 tablets. If 25 tablets are dispensed from the bottle, what percentage of the tablets remain? I. 5%. B. 25%. C. 75%. D. 95%. Answer: D. 95%. This question tests your ability to calculate a remaining percentage, a useful skill for inventory management. The concept involves determining the number of remaining items, dividing by the original total, and then multiplying by 100. First, find out how many tablets remain. 500 total tablets, 25 dispensed tablets equals 475 remaining tablets. Then divide the remaining tablets by the original total and multiply by 100. 475 divided by 500, asterisk 100% equals 0. 95 asterisk 100% equals 95%. Understanding percentages helps track inventory levels and prevent stockouts. Remember that remaining means subtracting what's gone from the original total. Question 13. A patient is prescribed 2 million units of penicillin. The available solution is 400,000 units/ml. How many milliliters are needed for the dose? I. 0.5 ml. B. 2 milliliters. C. 5 milliliters. D. 20 milliliters. Answer: C. 5 milliliters. This question tests your ability to calculate the volume of a liquid medication needed for a specific dose when given a concentration. The core concept is dividing the ordered dose in units by the concentration, units/ml. Here, the ordered dose is 2 million units, and the concentration is 400,000 units/ml, so 2 million units divided by 400,000 units/ml equals 5 milliliters. Accurate calculation of medication volumes is essential for patient safety, especially with antibiotics. Always ensure the units of the ordered dose and the concentration match before performing the calculation. Question 14. An oral suspension expires on June 30th. If it is reconstituted on June 10th and has a bud of 10 days, when is the earliest day it should be discarded? A. June 20th. B. June 21st. C. June 30th. D. July 1st. Answer B. June 21st. This question assesses your ability to determine the correct beyond use date, BUD, for a reconstituted medication, considering both the stability period and the manufacturer's expiration date. The concept is that the bud cannot exceed the manufacturer's original expiration date, and it is calculated by adding the stability period to the reconstitution date. If reconstituted on June 10th with a 10-day BUD, the calculated bud would be June 20th, counting June 10th as day 0, or just adding 10 days to June 10th gives June 20th. Since this date, June 20th, is before the manufacturer's expiration date of June 30th, the earliest discard date is June 21st, meaning it is still good through the end of June 20th. Always choose the earlier of the calculated bud or the manufacturer's expiration date. Question 15. A pharmacy purchases 10 boxes of gloves. Each box contains 200 gloves. How many individual gloves did the pharmacy purchase? A. 20. B. 200. C. 1,000. D. 2,000. Answer D. 2,000. This question tests your basic multiplication skills for inventory management. The concept is to multiply the number of larger units, boxes, by the quantity within each unit, gloves per box. Here, the pharmacy purchased 10 boxes, and each box contains 200 gloves. So 10 boxes * 200 gloves / box equals 2,000 individual gloves. This type of calculation is common in managing supplies and inventory within a pharmacy. Remember, when you have multiple containers of the same item, multiply the number of containers by the quantity in each. Question 16. A prescription requires 200 milligrams of a medication. The available stock is 80 milligrams per 2 milliliters. How many milliliters should be administered? A. 5 ml. B. 4 milliliters. C. 5 milliliters. D. 10 milliliters. Answer C. 5 milliliters. This question assesses your ability to calculate the volume of a liquid medication needed for a specific dose based on its concentration. The key is to use ratio and proportion to solve for the unknown volume. If 80 milligrams is in 2 milliliters, then you can set up the proportion. 80 milligrams / 2 milliliters equals 200 milligrams / x ml. Solving for x, 200 mg * 2 milliliters / 80 milligrams equals 400 / 80 is equal to 5 ml. This calculation is vital for accurately preparing liquid doses in various pharmacy settings. A quick way to think about it is to figure out the mg per ml first. 80 mg / 2 milliliters equals 40 milligrams per milliliter, then divide the ordered dose by this concentration. 200 mg / 40 milligrams per milliliter equals 5 milliliters. Question 17. How many pints are in 2 liters? Hint. 1 liter is almost equal to 11 pints. A. 105 pints. B. 11 pints. C. 22 pints. D. 44 pints. Answer C. 22 pints. This question tests your knowledge of converting between metric and household / apothecary units, specifically liters to pints, using a given conversion factor. The concept is to multiply the quantity in liters by the provided conversion factor for pints per liter. Here you have 2 liters and 1 liter is approximately 11 pints. So 2 liters * 11 pints / liter equals 22 pints. Accurate unit conversion is essential in pharmacy, as different systems are used in various contexts. Always use the provided conversion factor to ensure your calculation is correct. Question 18. A 1,250 with V solution contains how many milligrams of solute per 100 milliliters? I. 0,4 mg. B. 4 milligrams. C. 40 milligrams. D. 400 milligrams. Answer D. 400 milligrams. This question assesses your understanding of ratio strength and its conversion to a more practical unit like milligrams per volume. A 1,250 with V ratio strength means there is 1 gram of solute in 250 milliliters of solution. The question asks for the amount of solute in 100 milliliters. You can set up a proportion. 1g/250 milliliters equals xg/100 milliliters. Solving for x gives 1g * 100 milliliters / 250 milliliters equals 0,4 grams. Finally, convert 0,4 grams to milligrams by multiplying by 1000, which equals 400 milligrams. Understanding ratio strengths and converting them is crucial for preparing and dispensing solutions accurately. Remember that 1x with V means 1 gram of solute in x ml of solution. Question 19. A patient is taking 2 tablets of a 10 milligrams medication daily. How many total milligrams of medication are consumed in 1 week? I. 20 milligrams. B. 70 milligrams. C. 140 milligrams. D. 280 milligrams. Answer C. 140 milligrams. This question tests your ability to calculate the total amount of medication consumed over a specified period. First, calculate the total daily dose in milligrams. 2 tablets * 10 milligrams per tablet equals 20 milligrams per day. Then multiply the daily dose by the number of days in a week. 20 milligrams per day * 7 days per week equals 140 milligrams per week. This calculation helps in assessing patient adherence and tracking medication usage over time. Always determine the total daily intake before calculating for longer periods. Question 20. A pediatric dose calculation requires converting a child's weight of 44 pounds to kilograms. What is this weight in kilograms? I. 10 kilograms. B. 20 kilograms. C. 22 kilograms. D. 44 kilograms. Answer B. 20 kilograms. This question tests your fundamental knowledge of weight conversions, specifically converting pounds to kilograms. The key conversion factor to remember is that 1 kilogram, kg, is approximately equal to 2 pounds, lbs. To convert pounds to kilograms, you divide the weight in pounds by 2. So, 44 pounds divided by 2 lbs/kg equals 20 kilograms. Accurate weight conversion is critical for calculating weight-based medication doses for children, ensuring patient safety and efficacy. Always remember to divide by 2 when converting from pounds to kilograms. Question 21. A bottle of 60 tablets is dispensed with refills for 1 year. The directions are, take 1 tablet daily. After 6 months, how many tablets should the patient have remaining in their possession if they have taken the medication as directed and have not received any refills? I. 0 tablets. B. 30 tablets. C. 120 tablets. D. 180 tablets. Answer I. 0 tablets. This question assesses your understanding of day supply and medication usage over time. The key is to calculate how many tablets a patient would use within the given time frame. The patient takes 1 tablet daily. In 6 months, assuming an average of 30 days per month, or approximately 180 days total, the patient would have used 1 tablet/day * 6 months * 30 days per month equals 180 tablets. Since only 60 tablets were initially dispensed and no refills were obtained, the patient would have exhausted the original supply and would have 0 tablets remaining. Always compare the quantity dispensed with the quantity consumed over a period. Question 22. An 4 bolus of 50 milliliters needs to be infused over 15 minutes. What is the infusion rate in ml/hr? I. 50 milliliters per hour. B. 100 milliliters per hour. C. 200 milliliters per hour. D. 400 milliliters per hour. Answer C. 200 milliliters per hour. This question tests your ability to calculate an infusion rate in milliliters per hour when the infusion time is given in minutes. The concept is to first convert the infusion time from minutes to hours, then divide the total volume by that time. 15 minutes is equivalent to 0.25 hours, 15 minutes divided by 60 minutes/hour. Then divide the total volume, 50 ml, by the time in hours, 0.25 hours, which results in an infusion rate of 200 milliliters per hour. Accurate rate calculations are essential for safe and timely medication administration in hospital settings. Always convert minutes to hours by dividing by 60 before calculating an hourly rate. Question 23. A patient's prescription costs $45.00. Their insurance has a 20% copay. How much will the patient pay? I. $9.00. B. $12.00. C. $20.00. D. $36.00. Answer. I. $9.00. This question tests your ability to calculate a patient's copay based on a percentage of the prescription cost. The concept is to multiply the total cost of the prescription by the copay percentage. In this case, $45.00 multiplied by 20%, or 0.20 equals $9.00. Understanding copay calculations is essential for processing insurance claims and accurately informing patients of their out-of-pocket costs. Remember that a percentage copay is a portion of the total cost that the patient is responsible for. Question 24. A pharmacy has 12 boxes of flu shots. Each box contains 10 single-dose syringes. How many flu shots are available in total? I. 22. B. 100. C. 120. D. 220. Answer C. 120. This question tests your basic multiplication skills for inventory counting. The concept is to multiply the number of larger units, boxes, by the quantity within each unit, syringes per box. Here, the pharmacy has 12 boxes, and each box contains 10 syringes, so 12 boxes * 10 syringes/box equals 120 flu shots. This type of calculation is common in managing vaccine inventory and other multi-pack items in a pharmacy. Always multiply the number of larger containers by the quantity contained within each to find the total individual units. Question 25. An order for dopamine is 5 micrograms per kilogram per minute for a patient weighing 70 kilograms. The available solution is 400 milligrams in 250 milliliters D5W. What is the dose in mg/min? I. 0.035 mg/min. B. 0.35 mg/min. C. 3.5 mg/min. D. 35 milligrams per minute. Answer B. 0.35 mg/min. This question assesses your ability to calculate a patient-specific dose rate when given a weight-based order and then convert units. The concept is to multiply the ordered dose rate per kilogram by the patient's weight, then convert the units to match the required answer. First, calculate the dose in mg/min. 5 micrograms per kilogram per minute * 70 kilograms equals 350 micrograms per minute. Since the answer requires mg/min, convert 350 micrograms to mg by dividing by 1000. 1 mg equals 1000 micrograms, which gives 0.35 mg/min. This calculation is critical for accurate and safe administration of potent medications like dopamine. Always ensure all units are converted to the desired format for the final answer. Question 26. A physician orders a cream to be applied to 2% of a patient's body surface area. If the patient's total body surface area is 1.7 m superscript 2, how much area, in m superscript 2, should the cream cover? I. 0.034 m superscript 2. B. 0, 34m superscript 2. C. 3, 4m superscript 2. D. 34 square meters. Answer I. 0, 34m superscript 2. This question tests your ability to calculate a percentage of a given value, specifically a body surface area. The concept is to multiply the total body surface area by the percentage, expressed as a decimal, to find the specific area. To convert 2% to a decimal, divide by 100, which is 002. Then multiply 17m superscript 2 by 002, which equals 0034m superscript 2. This type of calculation is sometimes used for dosing certain medications or estimating application areas. Remember that a percentage must be converted to a decimal before multiplying. Question 27. How many fluid ounces are in 360 milliliters? Hint. 1 fluid ounce is almost equal to 30 milliliters. I. 6 fluid ounces. B. 9 fluid ounces. C. 12 fluid ounces. D. 15 fluid ounces. Answer C. 12 fluid ounces. This question assesses your knowledge of household to metric conversions, specifically converting milliliters to fluid ounces, using a given conversion factor. The concept is to divide the total volume in milliliters by the conversion factor for milliliters per fluid ounce. Here, you have 360 milliliters and 1 fluid ounce is approximately 30 milliliters, so 360 milliliters divided by 30 milliliters per fluid ounce equals 12 fluid ounces. Accurate conversions are essential for patient safety, especially when dispensing liquid medications with instructions often given in household units. Always use the provided conversion factor to ensure accuracy. Question 28. A pharmacy sells 35 prescriptions on Monday, 42 on Tuesday, and 50 on Wednesday. What is the average number of prescriptions sold per day for these 3 days? I. 35. B. 40. C. 42. D. 45. Answer C. 42. This question tests your ability to calculate an average, a useful skill for pharmacy operations and statistics. The concept of an average is to sum all the values and then divide by the number of values. Here, add the number of prescriptions sold each day. 35 plus 42 plus 50 is equal to 127, and then divide by the number of days, 3. So 127 divided by 3 days equals 4233, which, when rounded to the nearest whole number for practical purposes, is 42. Understanding averages helps in staffing, inventory prediction, and general business analysis. To find an average, always sum the data points and then divide by the count of those points. Question 29. A medication requires refrigeration between 2 degrees Celsius and 8 degrees Celsius. What is the equivalent temperature range in Fahrenheit? Use degree F equals degree C times 1/8 plus 32. I. 33, 6 degree F to 44, 4 degree F. B. 35, 6 degree F to 46, 4 degree F. C. 37, 6 degree F to 48, 4 degree F. D. 39, 6 degree F to 50, 4 degree F. Answer B. 35, 6 degree F to 46, 4 degree F. This question tests your ability to convert a temperature range from Celsius to Fahrenheit using the provided formula. The concept is to apply the conversion formula separately to both the lower and upper bounds of the Celsius range. For the lower bound, 2 degrees C times 1/8 plus 32 is equal to 3, 6 plus 32 is equal to 35, 6 degree F. For the upper bound, 8 degrees C times 1/8 plus 32 is equal to 14, 4 plus 32 is equal to 46, 4 degree F. Therefore, the equivalent range is 35, 6 degree F to 46, 4 degree F. Accurate temperature conversion is important for ensuring proper medication storage. Remember to apply the formula to each temperature point individually to find the range. Question 30. A hospital pharmacy has 3 cartons of vials. Each carton contains 25 boxes, and each box contains 10 vials. How many vials are there in total? I. 75. B. 250. C. 750. D. 1000. Answer C. 750. This question tests your ability to perform a multi-step inventory calculation involving nested quantities. The concept is to multiply the quantities at each level to find the total number of the smallest units. First, calculate the number of vials per carton. 25 boxes / carton * 10 vials / box equals 250 vials per carton. Then, multiply the total vials per carton by the number of cartons. 250 vials / carton * 3 cartons equals 750 vials. This type of calculation is crucial for managing inventory in bulk and ensuring accurate stock counts. To find the grand total, multiply the number of largest units by the number of medium units, then by the number of smallest units.